NAWPA is the North American Intergovernmental Committee on Cooperation for Wilderness and Protected Areas Conservation. NAWPA is a collaborative initiative fostering the exchange of ideas, experiences, best practices, and innovative solutions on shared conservation opportunities at the North American continental scale and across multiple agencies and jurisdictions. NAWPA, which was established in 2009, comprises 6 of the largest North American land and resource management agencies, which together manage 15% of the continental landmass. In Canada, it's represented by Parks Canada. In Mexico, by the Secretariat of Environment and Natural Resources National Commission for Natural Protected Areas. In the United States, it's represented by the Department of Agriculture, Forest Service, the Department of Interior, Bureau of Land Management, Fish and Wildlife Service, and National Park Service, as well as the United States Geological Survey, or USGS, which is a partner. Current work and projects of NAWPA include assessment of land-based conservation in North America. The USGS maintains a spatial database of North American conservation areas, allowing to evaluate the extent to which various ecosystems are conserved across North America. This helps illustrate where and how trilateral cooperation can enhance shared conservation goals. Second, there are efforts to enhance connectivity between conservation areas in North America. Analyses in 2 demonstration areas, the Great Plains and Californias, will help to identify approaches and opportunities to enhance connectivity between conservation areas in order to better conserve biodiversity and build environmental and social resilience in our rapidly changing world. In this presentation, I'll be discussing one of those 2 demonstration project areas. Our focus will be on the Great Plains and the temperate grasslands that occur from the Canadian prairies south across the western Great Plains of the United States and into the northern Mexico throughout the Chihuahuan Desert.
And what we've been able to do with this effort is take advantage of information that's more recently come on the scene through some of our efforts at NatureServe, along with a lot of others and USGS engaged, so that we could sort of think about and actually understand patterns of change in major temperate grassland types at this sort of continental scale, and get a better handle on this from a continental scale. What we concluded we would do is take advantage of this mapped information as well as descriptive information for major grassland types within this region, and focus on the 12 major types that our primary selection was based on our knowledge of approximate historic extent, and what were historically the predominant temperate grasslands that occurred across this large geography, and so that they would be this initial focus for our analysis. So we have mapped and described these types. Part of this comes from the work at a national level through the gap analysis program with USGS, as well as the interagency land fire effort. But we at NatureServe have been working at more of a continental scale and extended a lot of the good work that's happened within the United States into temperate Canada as well as across Mexico. So this gives you a sense of, each of these major types has a description associated with them. You could easily go to the NatureServe website, go into NatureServe Explorer, and you could do spatial queries in order to get access to the sort of descriptive material associated with the major grassland types. I will allude to this later on in the presentation, but I've captured the descriptive material for these 12 major types on a website that makes it available specific for this project. So taking a look at both the approximate historical extent as well as the current mapped extent of these major grassland types, we can really see these major patterns of land conversion that have taken place over recent centuries, basically. And a lot of this, we have known this really quite well, that a number of the tallgrass prairie types within this region have almost completely been converted for agricultural purposes. After all, this is very much the breadbasket of North America and portions of this geography. But what we're doing with this updated mapped information, I think, is getting a little bit more precise sense of really where do we stand in terms of long-term trends for each of these major grassland types. And I have most recently, in the last several years, been engaged with IUCN on sort of piloting what it might look like to establish a red list of ecosystems as a complement to the red list of species. And so some of the criteria for that red listing process really do get at this, the sense of long-term loss or conversion, and that this is how these particular 12 types stack up against the thresholds for scoring under the IUCN framework of critically endangered, vulnerable, or least concerned. And so you get a better handle on the variation. Mostly, again, they're tallgrass prairies from the Texas Blackland prairies, or northern tallgrass prairie up and around Minnesota into Manitoba, or the central tallgrass, into Illinois and extending east into Indiana, where these are, severely converted over recent centuries, basically the last couple hundred years of really intensive land uses. That is to be expected in terms of these results, but we could sort of see that more of a breakdown type by type across these major 12 types here. We've also taken advantage of a lot of the location information that results from field surveys of the member programs from NatureServe, the natural heritage programs that exist in each state. In Mexican states, Pro Natura is our representative in Northeast Mexico, as well as in the Canadian provinces. And so it's a reflection of priorities and field inventory to identify locations for species of conservation concern within each of those jurisdictions. And what we've done here is actually done just some analysis of that documented locality information for several hundred species that tend to be, pretty strongly associated with these major grassland types. And what you see here is just a summary of their conservation status as for this subset of species from these grassland types. And so you see, for example, G1 or T1, that is a species or a subspecies that is considered critically imperiled. You can see it broken down into these categories of simply birds, mammals, herps, invertebrates, and plants. Same goes with G2 is imperiled, G3 are vulnerable, or another way to look at status is again the IUCN status of critically endangered, vulnerable, or near threatened, and you see kind of the breakdown of species in these categories here, or the U.S. Endangered Species Act, be they listed as endangered or listed as threatened or candidates. This is how they fall out. COSEWIC is the Canadian, essentially the equivalent of the Canadian Endangered Species Act, and so you see the breakdown of species by category in the Canadian system, as well as in the Law 59 in Mexico, which gets at endangered as well as threatened or special protection status for species in Mexico. So this gives us an overall sense of a lot of at-risk species that are strongly associated with these major grassland types. We also wanted to take a look at, current representation of these major grasslands within protected areas defined in a variety of ways. And what you actually see on the left is one way of actually visualizing the proportion of historical extent of all major, uplands and wetland ecosystem types that occur from temperate Canada south into Mesoamerica and the Caribbean. And what I've done here is, because we have a lot of knowledge of that historical extent, we compare that to current lands that are categorized under the IUCN conservation status categories of 1 through 6. Now, we worked with the USGS, and part of the NAWPA effort was to bring together these national data sets. There is an updated protected area data set that is trinational in its spatial scope, and this reconciliation of different categories of land status and conservation status relative to these IUCN categories. So we were taking advantage of that particular case here. So what you see on your left, again, is the range of colors in terms of proportional extent of major ecosystem types across North America. And of course, you see a large gray area throughout the central Great Plains, as well as extending further east. That the proportional representation in protected areas is really quite low, especially across the nation's midsection in the United States, as well as the Canadian prairies. And on your right, you see this sort of tabular summary for these 12 major grassland types. In fact, they're very small proportions of these grassland types are currently found within designated protected areas, at least under the IUCN categories of 1 through 6. So there has been prior continental scale priority setting of places focused on these grasslands in this larger geography. Under the auspices of the Commission for Economic Cooperation, there has been an effort. The first round of this was in 2005, and they identified what they called grassland potential conservation areas. And these were, this was then refreshed as of 2010. In both of these cases, they were strongly driven by expert knowledge, as well as a lot of focus on grassland birds and habitat needs for grassland birds. But it was very much done from a continental perspective, thinking about these grasslands in general and their contributions to habitat for species in this geography. And so our intent was to take a look at bringing new information onto the table, and the NAWPA committee wanted to explore a couple of different options for how might we augment and build on this prior work. So one way to do this is actually under the Convention on Biodiversity, which really both Canada and Mexico are signatories to. There are what are called the Aichi targets, a series of targets for achieving different levels of conservation action and milestones as of, say, 2020. And one of those is Target 11. It says by 2020, at least 17% of terrestrial and inland waters terrestrial ecosystems and inland waters are conserved through effectively and equitably managed, ecologically representative and well-connected systems of protected areas. Now, there's a lot of room for interpretation as to what does that really mean? How would you approach ecologically representative as well as well-connected? What do you truly mean by protected areas? This is, as we know, is a very strongly private lands dominated region of the continent. Does this necessarily mean acquiring public lands? Not necessarily. There's a lot of interpretation of this, as well as just the idea of how would you measure 17%? What do you mean by 17%? Is it the current land area, or how might you measure that milestone of 17%? And so what we agreed we wanted to do here is approach an analysis focused on these major grassland types, getting at type representation and securing species habitat, and as one mechanism for advancing Aichi Target 11. And secondly, we would use that knowledge that we have now of really understanding the estimated historical extent by type as one way of measuring advancement towards. Sorry, there's somebody on the line that could you perhaps mute your line? I'm getting some feedback. Thanks. And so utilize this knowledge of estimated historical extent as a guidepost to help us understand how well are we actually capturing, representing that ecological diversity at a continental scale. And so we did some preliminary analyses using those earlier 2010 potential conservation areas, as well as the existing conservation lands, to develop some estimates and overlays with these major grassland types to get a sense of where might we be had we been advancing conservation within those GPCAs. And you can see a range of percentages by type that give us a sense that for some of these types, it's certainly achievable to move by that 17%, or at least approach that 17% representation objective. Whereas there's going to be other types that are pretty clear. Again, a lot of those tallgrass prairie types that have been very severely converted over through intensive land uses, that there's really no way we would be realistically able to restore that amount. And so that 17% milestone is not realistic for those. But this led us to sort of clarifying overall selection strategies for some updated potential conservation areas. So for some of these types, we would say it's overall an efficient representation, thinking about that 17% milestone as being realistic. And then another subset of these types, it's really to identify places that have the highest potential for targeted efforts at grassland representation. And then in total, we will at least have represented all of these major types in one form or another. So let me just sort of give you a high-level sense of the overall technical design process. What we're building on is really a lot of progress in systematic conservation planning over the last 15 to 20 years, really, and I have some references down below here that give you some sense of background on some of the spatial methodology tools and methods that got deployed in this sort of a context. And what I have here is just a couple of main bullets that you need to understand with the technical steps of the process. First is that we broke down and created a structure of 100 square kilometer hexagon spatial analysis units that really blanket this entire large geography, several tens of thousands of units. But what is important to understand here is that when we go to identify places, priority places on the ground, we're not trying to get any more precise than 100 square kilometers. In fact, we're talking about clusters of hexagon units of 100 square kilometers. So in fact, we're really trying to work at multiple hundreds of square kilometers to identify places. We're not trying to get more precise than that. There are subsequent planning steps that really would come into play to get to bring this to the ground. So this is, again, a continental scale analysis. Number two, we're thinking about representation of these major grasslands, and we're utilizing, as I've alluded to, that 17% estimate coming from the IEC Target 11 as a guide towards representation, and we're using that number based on our estimates of historical extent of these grassland types. So wherever feasible, we'll try to achieve that sort of representation level. Third, there's the notion of cost of selecting any one of those 100 square kilometer hexagon units. And what we'll use here, and I'll talk about in more detail, is a model of land use intensity. And what that gets at is where we have more intensive land uses, there's going to tend to be more conflicts associated with securing lands for grassland restoration and conservation. And so we're trying to attempt to represent those larger goals in areas of least conflict. And so we're going to represent cost by 100 square kilometer hexagon. Number four, though, we're going to say that the areas where we've already invested in conservation, existing protected lands, especially if they're of any substantial size, we presume that those were good prior decisions to establish those protected areas, and so we'll lock those in to the ultimate sort of solution here and build on those prior conservation investments. And then fifth, most importantly in my mind, is that we don't expect an analytical process with the available spatial data, as I've just outlined in 1 through 4, is really sufficient, and so we're going to bring in a lot of expert review and other data, such as other biodiversity distributions, a connectivity model, threats analysis, identified priorities in existing land management to really refine the output of this initial modeling process. So let me just take you through a couple of these technical steps. You can visualize this a little bit more. We're up on the U.S. and Canadian border, Montana, into Saskatchewan. And so what you see on your left is existing managed areas. Each of the NAWPA agencies are represented in different colors there. On your right is actually just a range map of one of the major grassland types, Northwest Great Plains mixed grass prairie. And using those 100 square kilometer hexagon spatial units, this is just quantifying how much grassland is within each one of those hexagonal units. So it gives you that sense of spatial resolution that we're actually shooting for in a continental scale analysis. So moving a little bit south, this is sort of looking at South Dakota into Nebraska. You can see sort of the Black Hills there. This is a model of land use intensity, and we're just publishing this particular model that extends across temperate North America, and it's really, we're publishing the methodology behind development of this model. And what it's done is it's integrated a lot of spatial data on roads, different land uses of different intensities, things like energy development and sort of concentrations of energy development are captured within this model. It's about 15 to 20 different layers, and each of those layers is represented with an initial assumption of intensity of impact where it occurs, as well as a distance function as to impact away from where that feature is located. And then it combines all these into an overall spatial index. And so you see in orange, that's sort of more high intensity land uses where they are concentrated across this geography. And so ideally, yes, we're trying to represent the grassland types within the areas that are the darkest green in this sort of context. So we've taken this model, which is a 90-meter spatial model, and then summarized it up to those 100 square kilometer hexagonal spatial units. And that this is sort of the foundation of this initial sorting of the landscape to try to understand how might we most efficiently represent those spatial goals type by type for each of these grassland types. And that this gives you a visual sense of what that might look like is that from each hexagon unit, just for that mixed grass prairie type, there's the area of grassland per hexagon combined with that cost index per hexagon. And so what we're going to do in our algorithm then is to pursue those hexagons that have the yellow to reddish colors sooner than we would those that move into the green and the blue shades in order to achieve that overall representation objective. And what that leads to is this initial draft characterization of these broader places where overall on a continental scale we might be able to achieve those kinds of representation goals. And that this output from an initial analysis is what we brought before individuals with expertise scattered across this larger geography. And we're bringing in additional information to look at these particular places and make refinements into the selection of those hexagonal units. So what you see here is this sort of contiguous grassland area where it currently is. Natural heritage programs, as I alluded to, have done systematic inventories within each of these jurisdictions. We can now summarize some of those the most imperiled of species just by 100 square kilometer hexagon here and sort of the density associated with those. It gives us a sense of where do we have a lot of really at-risk species occurring within this larger geography. We brought in other kinds of spatial models, including sage-grouse distributions, which sort of just get into a portion of the Northwest in Wyoming and Montana, especially portions of this larger study area. But certainly lesser prairie chicken is very significant here, and so we're bringing in both lek and habitat distributions for those species to help us think about and refine boundaries. Then we developed a landscape connectivity model that really applies across this entire continental geography. We were building on some methodology that Dave Theobald, he's with the Conservation Partners and formerly of Colorado State University, that he had developed this method. I have a citation for that model method down below there. And what this does is it uses that land use intensity model that we were using as a cost layer for selection. And then it's really using that to calculate how difficult is it to move amongst grassland patches. So this is that cost surface. We're now down on the Texas and Mexico border area into Chihuahua here. And what the model is going to do is generate actually a per pixel value of the relative probability of movement laterally amongst patches. And that this is one way to visualize that model. The heavier the red line is the greater probability that there is sort of a generic measure of connectivity amongst grassland patches. This is not attempting to be a connectivity model for any individual species, but more of a generic landscape connectivity surface. So again, we've utilized each of those components to help refine boundaries for these areas to represent the major grassland types. We then wanted to see, well, how do these line up with how others have done broader continental or more local scale analyses with at least some overlapping objectives. So what you see again here, the US and Canadian border region is some of those GPCAs are highlighted in blue from 2010, and how those actually overlap some of the priority conservation areas that were identified by the Nature Conservancy of Canada as well as the Nature Conservancy based in the U.S. across this entire geography. Now, both of those NCC and TNC efforts, I've been engaged in those for a long time, and that they really had a broader objective of actually representing the totality of biodiversity, but there's enough overlap certainly with our objectives here that they're a useful perspective to bring in. And so that you can see how those can then begin to connect to the selected hexagons that we've identified here. We also took advantage of where there were state wildlife action plans established state by state to look at where the grassland focus was the intent of some of the sites that had been identified in those plans, and see how those coincided or not with what had come out of our prior analysis. And so engaged folks to help us work our way through those and make further refinements there. So this is the overall result of working through that sort of analysis, identifying areas overall. The total square kilometers is quite extensive, 342,000 square kilometers are really extending from the Canadian prairies all the way through the Chihuahuan Desert. You can see how it's broken down type by type. Some of these types, we certainly were able to go beyond that 17% milestone as laid out by the IEG Target 11. And that would be expected in places or types such as the Western Great Plains Sand Prairie. The sandhills of Nebraska are really the major concentration of sand prairie. There are sand prairies elsewhere, but it certainly is one type, as well as the Northwest mixed grass, that we have opportunities. We have a number of opportunities to concentrate conservation of those grassland types, and so that 17% objective is fairly achievable with options out there on the ground. It gets more challenging as you go down the list, but certainly we were able to represent that, or at least get by that 17% number with some of the mixed grass prairie types. The Southeast Great Plains tallgrass prairie is really the Flint Hills in Nebraska, extending down into Oklahoma, and so as well as the shortgrass prairies, starting here in Colorado, extending south. That is something that we've identified to meet that milestone of 17%. But as we expected, there would be several of these tallgrass prairie types where that's far more challenging. The central tallgrass, the fescue mixed grass up in Canada, the northern tallgrass, and the Texas blackland prairies. But we did identify sites to represent each of those to be the focal areas for prairie restoration. And then you can see it down at the bottom, that overall percentage is about 15%. So you can see we're moving up towards that 17% overall objective with this overall design. So then what we did with this design is, just in a tentative sense, we clustered those hexagon units into a series of sites. They turned into 177 individual sites. We would put this as a very preliminary sense of a site, and that we're just trying to cluster nearby areas together and hexagonal units together, so that we can begin to summarize information associated with that subset of the geography. As you move into more specific site level planning, you're going to bring in a lot more information to actually decide what are the actual boundaries that you're working with for any particular conservation action or strategy. But this was just to help us organize this information at another level of detail, still coming from a continental scale. So what we did with those is then overlay those on the actual grassland distributions. We first wanted to quantify the sort of current extent of grasslands, the potential area based on the historical extent, so we can think about what is the actual area that might be the focus of conservation within each of these areas. We overlaid the existing protected area information. We want to quantify that current conservation investment, albeit relatively small in existing designated protected areas, but it's still substantial. We want to know what that is and how that breaks down across this geography. We overlaid sites from those other people's priorities, in that sense of really clarifying what is the common conservation focus from multiple perspectives, be it from the larger NGO community or for individual states. Where have other people also prioritize places that overlap with these. And finally, we did some overlays with that land use intensity map, and actually the components of that land use intensity map, the roads, the different land uses of different intensity, because those do represent a lot of common stressors that exist within each of these places. And so we wanted to at least do an initial quantifying of what's the nature of those stressors that do exist. So to give you a sense of this, the existing protected area investments, as we alluded to earlier, they're not very large overall, but we do have something here. We wanted to make sure we were capturing that. This is one way of summarizing that back up into by major grassland type across each of those 177 identified sites. By IUCN land protection status, you see overall it's a relatively small percentage, as we alluded to earlier, but we now have a more granular sense of exactly where have we made those investments and where do they fall within these different land management and protection status categories. There are others. There was an issue I alluded to a little bit briefly earlier. Within the United States, the reconciliation of protected or managed land status with the IUCN categories 1 through 6 is not perfect. And so there's one area that we were calling other conservation areas, and these primarily, like I say, fall within the United States, and they don't fit neatly into those IUCN categories, but we have quantified those areas as they relate to these newly selected GPCAs, as well as conservation easements. So we have the National Conservation Easement Database, and as that extends into Canada, and so this is quantified for those here. And then other people's priorities, so to speak, is that the Nature Conservancy or Nature Conservancy of Canada, how these overlay with those newly identified GPCAs. You know, as I mentioned, we fully utilized these to inform us as we were making refinements to the boundaries of each of these places, and so we would expect there to be a strong overlap. And in fact, it is about 85% or so of the overlap within these selected areas coincides with these from TNC and NCC. And then this is sort of another way of summarizing that land use intensity model by type. And what this is starting to point towards is I've ordered this by the proportional area of a grassland type that falls into some of the most intact landscapes. And so you could see stuff that is scoring with that landscape condition or intensity model up in the 0.8 to 1. Those should be areas where you start to think about core areas for conservation and extending beyond those. And you can see in some of the Chihuahuan desert types especially, the proportion of the selected areas that actually falls in fairly remote landscapes far away from intensive land uses is the highest. But as you go down into, again, as we've expected with some of the tallgrass prairie types, the higher proportions really do occur in some of the most intensively converted surroundings. And so they're going to definitely be more challenging. And you see that summarized in this table here. And you can sort of visualize that a little bit more, a bit of the spectrum of this. This is some related analysis in eastern South Dakota. And what you're really seeing is a portion of the northern tallgrass prairie, and where it extends, this is a portion of into the prairie pothole region on the sort of the eastern side of the screen. And as you move further west, you're kind of moving across into the mixed grass prairie. And so we're going from some of the most intensively converted portions of this regional landscape into some of the less intensively managed areas of the region. And what you actually see here is some pretty detailed analysis of using aerial photos to really identify where are there likely to be existing prairie remnants, where they'd be focal areas for conservation and restoration, based on pretty intensive work with air photo interpretation. We can kind of zoom in a little bit, and this is just a visual sense of that landscape intensity or landscape condition model that we used in this continental scale analysis. And so you can get a sense of the granularity of the information that we actually now have available across this larger geography. And this now is that a result of aerial photo interpretation as it relates to our model here. And so we do have a lot of more precise information underlying this analysis that we could take advantage of to better understand where are we within these particular selected larger geographies, and then begin to pin down what might be our strategies, what might be critical core areas, and where should we be taking action when. And this gives you a little more of a sense of it, kind of moving further into, this is into northern Colorado, the Pawnee Grasslands extending into western Nebraska and southeastern Wyoming. And one of those selected areas, now you see here numbers associated with the clusters of hexagons for each of these sites, so that you could see that draped on top of that landscape intensity model to see what are likely core areas and what are more intensive land uses that are associated with these landscapes, to start to bring this more closely to the ground. And what we can do now is see and summarize information associated with each one of those 177 units based on those components that went into that land use intensity model. So this is, again, summarized back up to the type by type analysis of the major grasslands, but these are the components of some of the components of that landscape intensity model. Roads broken down into 5 levels or 4 levels of actually expected traffic volume. Development from high to low, it's actually several categories of intensity of development. Agricultural, be it cropland or pasture, ruderal, invasive plants, where they are modeled and mapped. And so there's a list of a number of classes that we have them broken down by potential conservation area. So, again, working throughout this landscape, this is a region that is dominated by private lands as well as communal lands, especially in Mexico. The proportion of new designated public lands is not likely to be high. Most strategies should, we would expect to continue to focus on engaging collaboratively with people who currently live there on the ground and look for ways to move forward in productive ways. But that we want to highlight, there's a lot of analyses that can be built on what we've done here. Certainly we had a principal focus to do sort of continental scale analysis that focused on these major grassland types. So one of those immediate steps is to really integrate spatial priorities from other ecosystem types and species habitat needs. So there's, we focused on 12 major grassland types, but there are other less substantial types of uplands, both grasslands as well as woodlands and shrublands that are really characteristic of this larger region. We have not specifically integrated the perspective of wetlands and waterfowl and other migratory birds that are really focused on wetland and floodplain habitats, or those habitats themselves. And so that's certainly a next level of analysis to bring in and paint that picture. Nor did we address lakes and streams, and so from a purely aquatic perspective, that has not yet been integrated here. And so it would be logical to focus on that representation to round out the totality of major ecosystems in this geography. And next, to really update our assessment of land use trends, what we've done here is created a snapshot in time. It's a relatively current snapshot of lands and current conditions on this regional landscape. But we know that there are certain areas, certain portions of this larger region where the land use trends are quite a bit more dynamic. And some of those relate to, let's say, energy development, be it renewable or non-renewable energy. Development patterns can change quite quickly in different portions of this region. And so some level of analysis systematically to look at places that could change due to trends in energy development would be a worthwhile addition. As with cropland conversion, what we've seen in other portions of the Great Plains is changing changing crop values, as well as interactions with say, ethanol production and biofuels and other things can really quickly change land use patterns. And so getting a better handle on are there portions of this regional landscape that are more vulnerable to rapid change would be a really worthwhile addition here. We have not addressed, in this case, climate change vulnerability, and so we have established methods to think about and quantify our understanding of climate change vulnerability from the perspective of habitats and or individual species. And so this is certainly a worthwhile investment to consider in a focused way so that we can clarify and begin to foresee the nature of change that might be just over the horizon relative to these major grassland areas, because it really supports identification of adaptation measures so that we're really working effectively in conservation within these places with that in mind. And finally, this is a perennial area where, and coming from NatureServe and the Natural Heritage Network, where we do a lot of field surveys for biodiversity and are trying to keep information current about where are important habitats and species and places for conservation. There's a continual need to invest in field surveys to really keep current our understanding of where habitats are and conditions are in the landscape, and so that we're acting on the most reliable information when it comes to taking conservation actions. So with that, I just want to thank all the many contributors to this effort over the last couple of years. There has been representation from across all three countries and a lot of the individual jurisdictions. And what we'll be doing is sort of identifying some of our final products. And what I want to be able to introduce you all to is once we are about to submit a manuscript to the Natural Areas Journal that summarizes this analysis. And then we've also created a website on Data Basin that helps provide access to sort of project summary information as well as maps. And so I'd like to introduce folks to that. What I want to do is do just a quick introduction orientation to the website we have set up for this effort. Data Basin, if you're not familiar with it, is a site you could go to. You could establish a free account. I encourage folks to do that. It gives you a lot of access to a lot of information. A lot of data sets can be accessed through here, as well as just other projects of interest that you can learn about fairly quickly. It has a lot of querying capability, and so you can find a lot of information here that you might not have known was available. And what we've done here for this effort is then created what's called a case study. And what it does is that it just simply allows us to create a fairly brief characterization of the project overall, and then it points you to different components. So an overall case study is that introduction to the effort, and then it gives you the opportunity to connect to what's called a map gallery. And so in a gallery, then you could click on that, and this sort of takes you through some of that same information, but then it allows you to have different folders. So I have documents and presentations can all be stored in this place. And so what I have right there, if you were to open up the documents menu, you would see, for example, a PDF of those grassland type descriptions. You see some of the tables that relate to those individual 177 different sites and some of the characteristics associated with each of those places. Grassland species, that's the sort of the master table that I was using to help characterize what we know about species that are strongly associated with these different grassland types. And then presentations. There's this presentation you've just seen is actually already posted there. And once we have a recording of this, then we'll post that recording up in that folder. And so it's a nice opportunity to be able to share information, share documents. And some of those tables, this is that example of looking at a species table. There's many, hundreds of species that are captured here because this is a continental scale analysis. There's a lot of data associated with many species here. These are all species that are tracked in one form or another by one of the NatureServe member programs as they fall within within this larger study area. And then you could go back into that case study area, and you could click on, this is just the example of a map project that I have. This is called the NAWPA webinar, is what I've got here that we can look at live. And so this is another real important feature of Databasin, is it allows you to basically function with ArcGIS online. And so it gives you a lot of basic orientation of being able to create files, add data sets to it, to visualize, to navigate, and gives you a lot of access to this sort of information. And so for example, one might want to take a look at a particular site, and then you could open up the spreadsheet table from the folder of sites, the site table folder, and then you can look at the content associated. This is again, here in Colorado, it's the Pawnee Grasslands geography here, and then this is predominantly shortgrass prairie, the total area that falls within those selected hexagons, and then the total area, historic extent, current extent of the grassland, the roads and different land uses associated with each of those. This is all summarized in this tabular sort of structure for each of these sites. And so you'll see on screen a number associated with the cluster of hexagons, and that relates to this site number in this table. So there's a lot of information accessible to all the components of this particular project. So let me actually jump over to that right now. And what you see here is that the overall case study, and I'll be adding some more content to this as time goes on. We could go into that particular map gallery, and again, I'll be adding more as we publish the article associated with this. I will post it in the documents folder, and then we could work into the actual map viewer. And so again, what this allows you to do is navigate around. You could move around and understand, zoom in, zoom out, to better understand what you're looking at in particular places. You could add more information to this. Let's say this is actually a different data set I pulled in. You add data sets, and it'll take you out on Databasin, and you could find other similar data sets that you're interested in. You bring them into your project. This is one that was the Great Plains plow print. So here's a data set here, and I could look at that, bring it into my project, and it's sort of more intact grasslands versus plowed areas. How does that relate to any one of my sites here that I'm interested in? Here in this case, the lesser prairie chicken and the sage grouse. How do those relate to any of these sites that we've identified? The cost of selection per 100 square kilometer hexagon, that is represented here in this layer. And so you can really access a lot of information in an online way, just to navigate around and understand the places that have been identified. How does it relate to other information? Then you could download the data. You can, in this case, what one can do fairly easily on Databasin is download from the scene that you are looking at. You can download things like PowerPoint slides or PDF or PNG sorts of files if you want to bring them into a presentation, for example. And so it has a lot of real power and utility of simply making this kind of information accessible to anybody who's got an internet connection. Like I say, all one really needs to do is it's helpful to establish a free account on Databasin, and then you could begin to save you could set up your own project and you save it, and it'll be in your folder so that you can go back to it and find it and build on it from there. And so that was our intent, is to organize and approach this effort so that all of the data that can be made freely accessible is made accessible to everyone who's interested in taking advantage of it.